Hello dear students, welcome you all. This is Anirudh Singh Rathore, and from today we are going to start one short series on this Gate Wallah English channel. In this one short series I am going to start subject strength of materials, and in every lecture I will be dealing with one topic, one specific topic, and I'll try to keep it as concise, as small, as short as possible while covering all the concepts. So in today's class, we are going to discuss stress and strain. So this is the lecture 1. Obviously, we are going to start from today. So in this class, we are going to discuss stress and strain. So what all topics we are going to discuss in this class? First of all, we will be discussing stress, then types of stress, then strain, and then types of strain. Okay. So first, let us all start with stress. What is stress? As you can see, this is a rope, and there is a tug of war competition going on in between a group of students. When they are pulling this rope, some stress is coming in the rope. Now what is this stress? See, when these groups are pulling, when these boys are pulling this rope, there is some external load applied on the rope, and in response to this external applied load, there will be some elongation in the rope. Now this rope's material will resist against that elongation. So there will be some internal resistance generated in the rope as response to the external applied load. So whenever I will apply some external load, what will happen? The material will try to deform under that load. And to prevent that deformation, some internal stresses will be generated in the member. So these internal resistive forces are called as stresses. Okay. So is this clear? What are the stresses? External load is applied, it will try to deform. To resist that deformation, some internal forces are generated. These internal forces are called as stresses. Clear? Okay. So that means the stresses will come only in the part where there is external applied force, and where there is no external applied force, there will be no stress. So stress will be coming in this part. Definitely stress will be coming in this part. What about this part here? Here there is no externally applied load, so there is no stress in the rope here. Okay, right. So how can we define stress? The definition of stress is very clear. Stress is the internal resistance of a material to the distorting effects of an external force or load. So external force or load will try to distort the material, and the resistance against that distortion will be the stress. Okay, very clear. Now normal stress. What is the normal stress? Stress that will be acting perpendicular. Okay, so the normal stress or perpendicular stress is defined as the load per unit area. Okay, simple definition: load, external load divided by the area of the cross section. So it will be expressed like this: stress is equal to P by A, and the unit of stress will be the unit of force divided by area. Okay, so force unit will be Newton, area unit will be mm square. So like this, there will be several units of stresses like Newton per mm square, or kilonewton per mm square, or kg per centimeter square, etc. So this is all about the definition of stress. So let us see what are the different types of stresses. Okay, so first of all, let's move on to the broad classification of stresses. So if we classify broadly, there will be two types of stresses. One will be normal stress and other will be tangential or shear stress. So as the name suggests, normal stress will be acting perpendicular to the cross section. Normal means perpendicular. So perpendicular to the cross section, either towards the section or away from the section. Okay. So normal stress, perpendicular. Let us see sub classification also. So normal stress can be of three types. First type of normal stress is direct normal stress. Then second is bearing stress, and third is bending stress. So what is this direct normal stress? So direct normal stress, suppose if we are having any object is there, and if we have applied loading that is passing through the axis of the material. Okay, so along the axis, if I apply a load that will compress it, that will produce compressive stresses along the entire length of the material. So at each and every cross section, if I see, there will be compressive stresses, and sign convention of compressive stresses is taken as negative. Okay, then there can be pull also. We can apply pull along the axis of the member. So if this is the member, and along the axis if I have applied tensile forces, then there will be tensile stresses generated, and these will be termed as positive. So sign convention of tension will be positive. So these are perpendicular or normal stresses. Then let's come to the bearing stresses. How bearing stresses will be acting? So suppose there is a material and there is another material kept on it. Okay, so weight of this material is pressing against this material. So what will happen? There will be some compressive stresses at the contact surface area. So if this is very heavy, it will be producing some very large amount of contact surface stresses. Okay, so these are always in compressive in nature and sign will be minus. So if this weight is pressing against this, if this weight is pressing against this, then what will happen? Here we will have some compressive bearing stresses. Okay, one material is bearing over another material. So these will be on surface only. So these are the bearing stresses. These are again perpendicular to the section. Then let's come to the bending. So in bending, although it looks like that these are transverse, but these are occurring because of the bending. So when we are bending the material, what is happening? The longitudinal length is going like this. Okay, length along the length it is going like this, but if we look at the cross section, what is happening? The upper part is shortening and lower part is getting elongated. So bending stresses are also perpendicular to the cross section. Okay, so when we look at the cross section, we will see that one part is having, half of the cross section is having compressive forces or compressive stresses, and half of the section will be having tensile stresses. Okay, so these are again normal or perpendicular to the surface area. So normal stresses are classified into three categories: direct normal stress, bearing stress, and bending stress, right? Now let's come to the tangential or shear stresses. So normal stresses will be perpendicular to the section, or tangential or shear stresses will be parallel to the section. Okay, when the force is applied parallel, then we will get tangential or shear stresses. Okay, so now let's have look at the different types of tangential or shear stresses. First one will be the direct shear stress and second one will be the torsional stress. So when we look at the direct shear stress, let us consider a block, an element or a material is kept like this and we have fixed it with ground. Okay, we have used the Fevicol ka mazboot jod and we have fixed it with ground, and now if we apply load like this parallel to the section, parallel to the surface area, the tendency of this load will be to deform the shape. Okay, it will not change the length of the member, but it will deform the shape. So here we will be having some angle, and initial angle was 90 degree in this case. Now final angle will not be 90 degree, it will be some changed angle. Okay, so this is the direct shear stress when direct applied force is causing the shear. Okay, then next we will have torsional shear stress, and torsional shear stress is generally on shaft of cylindrical shape. So when I am having a shaft of cylindrical shape and if I am applying the moment that is along the axis of the member, so this is the axis, like this I am having the axis of the member, and when I am applying moment like this, then it will create torsion. Okay, so case of torsion will be case of pure shear when I apply like this. Okay, when I apply moments like this, then it will create case of pure shear. There will be no axial forces, there will be no bending moments, there will be only torsion, there will be only shear stresses. Okay, so tangential or shear stresses can be of two types: direct shear stress or torsional shear stress. In torsional shear stress, what will happen? One plane and other plane, these planes will slide with respect to each other. Okay, in longitudinal direction they will look like this, but if you look from side, then they will be sliding against each other, so they will be causing shear. Okay, so normal stresses are of three types: direct normal stress, bearing stress, and bending stress. And tangential or shear stresses are of two types, that is direct shear stress and torsional shear stress. Okay, now let's look at some practical real life examples. Okay, so suppose this is a student studying online on Physics Wallah channel, and let us say that this student is sitting on a chair, and if you observe this part of the chair, this element of the chair, okay, the entire load of this student is coming onto this part, so it is causing some compressive force. So this part will be having direct normal stresses of compressive in nature. Okay, so here we will having a direct normal stress, compressive, Let's look at some other examples. Consider this part. The car is being towed away by a tow vehicle, and this vehicle is saying sorry for towing your vehicle, but still it is towing. So here look at this part. Okay, so this region can be considered as it is fixed to this part, but this part, on this part we can see that some load of car is acting here. So let us say P load is acting. So in this part we will be having some shearing stresses also. Okay, this P load is acting parallel to the section. So all these are cross sections, and P load will be causing sliding like parallel to the cross section, and this will be causing some bending also here. Because of this, some bending will also occur. So bending moment will occur, bending moment will cause normal stresses. So in this part we will be having shear as well as bending stresses. Okay, let's look at another example. So in this part, this car is hanging over these ropes. Okay, when these ropes, can you guess what will be the stresses in these ropes? In these rope stresses will be tensile. Okay, tensile stresses will be coming. Can you guess the types of stresses in this part? In these parts, stresses will be bending. There will be bending. What will be the stresses where these two parts are connecting here? This part and this part is connecting at the contact surface. At the contact surface, we will be getting here bearing stresses. So at this part, we will be having bearing stresses. Okay. So like this, you can see in your day-to-day life, everywhere there will be stresses at one element or at the other element. In the door handle also there will be some stresses. On the ceiling fan also there will be some stresses. So just try to observe all around yourself and see what are the types of stresses that each element is witnessing. Okay, let's move further. So this is the steering wheel of a car. On this steering wheel, when we try to turn the steering wheel of the car, what will happen? Let us say we are applying some force in this direction, other force in this direction. Like this, only we turn it. Okay. So let us say P force is acting here, P force is acting here. The distance between these two is, let us say, A distance. So total torque will be applied P into A. So total torsional moment will be applied P into A, and this torsional moment is transferred to this shaft, and this shaft will transfer this torque to some other mechanism that will turn the wheels. Okay, so in this shaft there will be torsion. Okay, so torsion will cause shear stresses in this shaft. Okay, so everywhere we can see there are several types of stresses. Here also this is a shaft. In this, torsion will be occur. There will be torsion in this shaft. Okay, so at this, okay, this shaft is connected with a lever. On this lever some weight is hanging. So this weight is causing this downward movement here, and because of this downward movement, in this we will be having shear and bending. Shear and bending will be occurring in this part. What about this part? In this part there will be torsion. Okay, so along the axis, about the axis, there will be a movement like this. Okay, so this is the central axis of this member, and about this axis there is movement, and that will try to rotate it. So when it will try to rotate it, there will be torsion in this part. Okay, so these are few of the examples. Now let's come to strain. Now when there is load applied, there will be tendency of the material to change its shape or change its length. So when the length or shape of the material is changed, that change we represent in terms of strain. So what is the strain? Strain is basically the deformation. But how we express that we'll understand later on. So strain is the deformation or displacement of the material that results from an applied stress or applied load. So applied loading will cause the deformation, and that deformation is represented in form of strain. Okay, now it is simply the ratio of change in length to the original length. So when we talk about normal strain will be change in length to the original length. Normal strain is represented by epsilon, and it will be represented by change in length divided by the original length. Now can you tell me what will be the units of strain? What will be the units of strain? So change in length, their unit will be length, divided by length, again unit of length. So both units will be cancelled out. there will be no units of strain. So strain will have no unit. What? How can we express it? We can express it as percentage, or we can express it as a fraction. Okay, so these are the strains. Now let us see what are the various types of strain. So strains are classified into two categories, only two categories. One is normal strain and other is tangential strain. So just like we have observed the stresses, the strains will be of two types only. So what are the two types? Suppose there is an element, there is a material. Okay, let us say this is a prismatic bar and I am applying some tensile force on this. So tensile force will create tensile stresses that will be normal stresses, and this will result in elongation. So original length was, let us say, L, but after applying the force it has elongated by an amount delta L. So strain we can write here in this case delta L by L, and this will be the normal strain. So if stresses are tensile, stresses are positive. If stresses are compressive, then stresses are negative. Similarly, in this case, tensile strain will be positive and compressive strain will be negative. Okay, so we have seen sign conventions also. Now let's look at the tangential or shear strain. So if on this body, if I apply any force like this parallel to the section, it will try to distort the shape. So shear strain or tangential strain, the force will be acting parallel to the section. If the force is acting normal to the section, then it will try to change the length, just like this case. So when it is acting perpendicular, then it will change the length. But when it is acting parallel to the section, it will distort the shape. It will not change the length. So distortion of shape is taking place. The angle here was originally 90 degree. Now the angle is something else. So this change in angle is represented as strain. So what is the tangential or shear strain? The angle change that is taking place here. So that we can represent it by phi, or we can represent this strain by gamma. So gamma will be equal to 10 gamma, approximately equal to 10 gamma. Why? Because these angles will be very small. So for very small angles, gamma and 10 gamma we can take equal, and that will be equal to, let us say, the shift of this point is delta here, and this length was L. This length was L. So we'll get delta by L. Okay, so this will be the shear strain or tangential strain, right? So normal strain and shear strain or tangential strain are clear. Now we have seen the sign convention of normal strain. Let us look at the sign convention of tangential or shear strains also. So this much is clear: when shear strain is applied, then angle will be changed between the two faces. Okay, so whatever be the two faces, the angle will be changed. So when angle is changed, it can distort like this also. The distortion can occur like this also, or distortion can occur in opposite way like this also. So these are the two types of distortions that can take place due to shear. Okay, it looks like the lengths are changing, but lengths will not change. It is just while I am representing, then it looks like that lengths are changing. So lengths are not changing. Now, which one of the shear strain will be positive? Let us see. This phase is positive x phase, this phase is positive y phase, this phase is negative x phase, this phase is negative y phase. Okay, if we take x direction here, y direction here, so just look at the perpendicular to that phase. So if perpendicular to that phase is going in positive x direction, then this phase is called as positive x phase. Perpendicular to this phase is going in positive y direction, so this is positive y phase. Perpendicular to this phase is going in negative x direction, this is called as negative x phase. And perpendicular to this phase is going in negative y direction, so this phase is called as negative y phase. So these are the two positive phases, these are the two positive phases, these are the two negative phases. So when angle between two positive phases or two negative phases is reducing, then it is called as positive shear. When angle between two positive phases or two negative phases is reducing, then we call it as positive shear. And when angle between two positive phases and two negative phases is increasing, then we call it as negative shear. Okay, so angle between two positive phases is reducing, then angle between two negative faces is also reducing. So when angle between two positive faces and two negative faces is reducing, then it will be called as positive shear. And when angle between two positive faces and two negative faces is increasing, then we call it as negative shear. So this is the sign convention of shear strain. Okay. Now let's have a look at some questions. Okay, so this question was asked in ESE 2008. What is the nature of stress in a ceiling fan rod? So ceiling fan rod, let us have a look at a ceiling fan. So here we are having a ceiling fan, and this ceiling fan rod is carrying weight of this entire part. So this weight is acting downwards, so it is pulling the ceiling fan rod down, but the roof is pulling it up. So there will be a tensile stresses in the ceiling fan rod. Okay, so correct answer will be option B. Next question. A bar of varying square cross section is loaded symmetrically as shown in the figure. So this is a bar of varying cross section. So cross section is square. So here the dimension is 50. So this is the square of 50 by 50, and this is the square of 100 by 100 cross section. Okay. Now loads are acting symmetrically. They are acting about the central axis. Now 50 kilonewton load is acting on this part only, and on this part 100 plus 50 plus 100, 250, total 250 kilonewton load is acting on this part. Okay, so 50 kilonewton that load is acting on this part will be transferred to this part also. Okay, but these 100 kilonewton will not affect this one. Okay, so what we have to find out? We have to find out the maximum stress that is occurring in anywhere. Okay, so we can take two cross sections, we can take two sections, we can calculate stress at this section, and we can calculate stress at this section. Whichever stress is higher, that will be the maximum stress anywhere in the structure. Okay, so let us first try to analyze stress at one location, location 1. So sigma 1 will be equal to force per unit area. What is the force? Force is 250 kilonewton. So 250 into 10 to the power 3. 10 to the power 3 we are doing to convert this kilonewton into Newton. Okay, so we have converted this into Newton. Now what is the area? 100 mm into 100 mm. That means 100 into 100 mm square. Okay, so this is the cross sectional area. So this will come out to be 25 Newton per mm square. 25 Newton per mm square. Okay, so this is sigma 1. Now let us calculate sigma 2. Sigma 2 will be equal to force divided by area of this one. Okay, so what is the force? Force is 50 kilonewton. So 50 into 10 to the power 3 Newton divided by area will be 50 into 50, 50 into 50. So this will come out to be 1000 by 50, yani 100 by 5. That means 20 Newton. 20 Newton. So that means maximum stress will be greater of these two. That means 25 Newton per mm square. So correct answer will be option C. Let's move on to next question. This question was asked in GATE 2017. Okay, so in a material under a state of plane strain, a 10 by 10 mm square element is taken, and when stress is applied, it is deformed like this. Okay, so initially this angle was 90 degree, and after that the angle, after distortion, the angle becomes pi by 2. That means 90 degree plus 0.0005 radian, right? If the shear strain gamma xy at this point is expressed as 0.001 K, 0.001 K, so gamma xy is expressed as 0.001 K. We have to find out the value of K. So gamma xy is given like this. So what will be the strain at this point? Shear strain at this point will be change in angle. So earlier the angle was 90 degree. Now the angle is pi by 2 plus this. Okay, so 90 degree plus this. So change in angle will be this much, and this is equal to gamma xy. So gamma xy will be equal to 0.0005 radian. Okay. Now, can you tell me if this strain or this shear strain is positive or negative? So angle between two negative faces is increasing. Angle between two positive faces is also increasing. So when angle between two positive faces or angle between two negative faces increases, then it is negative shear strain. So this we will write as minus sign. Okay. Now this is expressed as this. So 0.001 K will be equal to minus 0.0005. So K will come out to be minus 0.5. So value of K will come out to be minus 0.5. This will be the answer, option D. Okay. Okay. So in today's class, we have discussed what are the stresses, what are the types of stresses, what are the strains, what are the types of strains, and we have seen the sign conventions of them all. Now, let us finish this class, and I hope you liked this class, you enjoyed this class, and we'll keep on continuing, keep on learning. So, let's meet up in the next class. Bye-bye. Take care.